All right, 5-6 is the quadratic formula. Quadratic formula is yet another way to find the zeros. So like I said on the 5-4 video, if you can factor it, factor it. That is the easiest and quickest way to find the zeros or solve a quadratic. If you can't though, that's when you have to do the either completing the square or quadratic formula. Personally, I like the quadratic formula better than completing the square, but it's up to you. So here's our quadratic formula. I'm sure you've seen it before and heard little songs and everything to remember it. If you need to look up one of those songs, go for it. I'm not going to sing one to you because you would cry. Okay, so the discriminant is the part of the quadratic formula that is underneath the root. So it's the b squared minus 4ac piece. And we have 3 different rules just based on that discriminant on the types of solutions that we have. So if this is positive, greater than 0, you're going to have 2 real solutions. So that means you are going to have a graph that crosses twice. If you have the discriminant that is equal to 0, that's going to give you something where the vertex is right on the axis. Okay, we've looked at those before. That's what one solution looks like. And if that discriminant is less than 0, that means we're going to have a no solution problem. So that means that that parabola is either floating above or below the axis and never touches it. Okay, and this also comes from your properties of square roots. When you take the square root of a number, you get 2 answers, your positive and negative answer. That's why the formula has the plus and minus already in it. If you take the square root of 0, you only get 1 answer, 0. And up until this point, you can't take the square root of a negative, so that's why you get the non-real solutions or no real solutions at that point. Starting tomorrow, we're going to do imaginary numbers, so you will be able to take the square roots of negatives. Isn't that exciting? I can't wait. Okay, so the 2 examples we're going to do here it says we want to use the discriminant to tell how many solutions we have and then solve it using the quadratic formula. So quadratic formula, you have to have it in standard form. So I'm going to move this 12x over to the other side. That's the first thing I'm going to do. And then if you want to write out what your a, b, and c are, go for it. A would be 1, b would be negative 12, c would be 36. So now let's plug that into the discriminant. So the discriminant is this guy. So I'm going to have negative 12 squared minus 4 times 1 times 36. This, I would suggest just plugging the whole thing right into the calculator just like that. Make sure you use parentheses, because if you don't, you're going to get a wrong answer. You could actually leave out that 1 because we know multiplying by 1 doesn't do anything. Oh, look at that. I get 0. So that should tell us that we are going to have 1 real solution. Okay, now let's actually find that solution. Now some of you may have noticed this is actually factorable and it's actually a perfect square trinomial. So this would actually be one that I would factor. But we're going to go through this process just so that you can see you still get the same answer either way. So now plugging into the quadratic formula. I have negative b, so negative 12 plus or minus square root of, this we already found, so I'm just going to put that 0 right underneath, over 2a. Now let's do some simplifying. So negative 12 becomes positive 12, square root of 0 is 0, 2 times 1 is 2. So what I have here is just 12 divided by 2, which is 6. So that is the spot where this quadratic would cross the x-axis. It would sit right on the axis at 6. All right, example 2. So we're going to start out the same way. I have this in standard form already. So here's my a, b, and c. Let's find the discriminant first. So b squared minus 4ac. So negative 16 squared minus 4 times 2 times 27. And I am going to plug that whole guy into the calculator. And I get 40. Okay, so now that tells us, since we have a positive answer, I'm going to have two real solutions. So it's going to cross the x-axis twice. Now let's plug it into the rest of the quadratic formula. So I have negative b plus or minus square root of the discriminant is what we found, so that's 40 all over 2a. Now we'll do some simplifying. Okay, 40 I need to simplify. In Algebra 1 you can get a decimal answer, Algebra 2 no way. So root 40 is going to split into root 4 and root 10. I'm going to simplify that root 4 to a 2. Okay, at this point I'm actually going to break this apart into 2. You have to remember whenever you have addition or subtraction and then division, that has to go to both of those. So this is going to actually become 16 divided by 4 plus or minus 2 root 10 over 4, and then I can simplify those because 16 divided by 4 is 4, and then those I can simplify. 2/4 are both divisible by 2, so this is actually going to become root 10 over 2. So this is my answer. Now if you want decimal approximations, you can type that in and see what you get. So we would have 4 plus root 10 divided by 2. So that's about 5.6, and then you'd have 4 minus root 10 divided by 2, and that's 2.4. So those would be your two approximate answers of where that graph would cross. And you can always type it in to look at it too and make sure that it matches up. Alright, last one we have the story problem. Application problem, I should say. Alright, so we have an athlete on the track team who is throwing shot put. The height y of the shot put in feet t seconds after it's thrown is modeled by this function. The horizontal distance x in feet between the athlete and the shot put is modeled by x equals 29.3 t. To the nearest foot, how far does the shot put land from the athlete? We have a lot going on here. We actually have 3 variables, so this is kind of a multi-step problem. So to keep organized, I'm going to make a little list over here. H is height, and that was in feet, not H, sorry, Y is height. T is time in seconds, and X is distance, the horizontal distance, so side to side. That's also in feet. Okay, so if you think about what's happening here, we have our person throwing the shot put. It's kind of like those projectile functions that we talked about. This was our time, and this is our height. I guess I should call that height, shouldn't I? Okay, so first thing we can do is we're going to use the quadratic formula to find this time where it hits. Then we're going to come back to this. So let's do the discriminant first, b squared minus 4ac Alright, so I get 1021.16. So that's my discriminant. We're going to have 2 solutions. We should kind of predict that. So now let's plug it into the whole quadratic formula. Negative b plus or minus square root of the discriminant all over 2a. Alright, so this is going to give us, I want a decimal answer here because we're talking about a real life problem. So I'm going to add this. I have 1021.16. So I want to get as close of an approximation as possible. And then that's going to get divided by negative 32. So this gives me my one answer, negative 0.23 seconds. That does not make sense. So that's going to be the answer we're not using. The other one is going to be the same thing, only minus. move this up so you guys can see what I'm typing in there. This gives me about 1.77 seconds. Think about that as a logical answer for shot put. That seems logical. So that tells us how long the shot put's in the air. But what the problem was asking us is how far did it go? So if we go back up to our problem, we have this little function. X is really what we're trying to find. So we just found t, wants us to find x. We can plug that in. So if x equals 29.3 times this 1.77 stuff, I'm actually just going to take this answer because this is more accurate than rounding it off and multiply that by 29.3. And I get 51.78. So it says to the nearest foot. So that would be about 52 feet is how far that would travel. Okay, awesome. So make sure you do the last two there using the quadratic formula. And for your joke of the day, what do cannonballs make when they want to start a family? They make BBs. Ha ha ha, get it, BBs? All right. Well, hope you guys have a great night and good luck with the quadratic formula. I will see you tomorrow.